Okay, so we are going to be talking about section 3.3, which is graphing quadratic functions in vertex form. And I have some things here, but we'll come back to this later. It'll make a little bit more sense after we play around a little bit with this, and so you can kind of see what's happening with it. Okay, so in order to try and figure out a little bit about vertex form, we're actually going to play around a little bit with a graphing calculator so we can kind of see what's happening here. So notice that this is vertex form of a quadratic, and that's what we're specifically talking about today, is that form. So notice that there's an A, H, and K, and those will be, there will be numbers that will be put in those places. And so what we're going to do is we're just going to kind of look at a few things here and just try and figure out what each of those things do. So I have these sliders, and so right now it's just kind of a normal standard parabola. We call it a parent function. It's the y equals x squared. And as we change this, it's going to change the shape of the parabola. So notice what happens when I slide this and make the numbers bigger. What do you see happening?
Gets thinner.
Yeah, it's getting skinnier there, right? So as the number gets bigger, it's getting skinnier and skinnier. And then look at what happens between 0 and 1. You see how that's kind of getting wider than it was before? And then when it's negative, it's going to flip it over. Oh, didn't quite, well, I guess I'll do that for right now. It's going to flip it over that x-axis. Okay? Or, so, yeah, the x-axis. And now let's look at H and see what it does. Actually, I'm going to move this back up so it's back to 1. So A is 1. All right. So now let's just move the H, that slider there. So we can see that it's moving it left and right. Okay, but this one's kind of a tricky one, looking at the equation to be able to tell what it's doing. Because notice up here in my equation, I have x minus h. All right, so when I put in this h is -3, I'm really doing x minus a -3, which would be x plus 3. So if I have x plus 3, it's moving that parabola 3 places to the right. Okay, let me see here. And then these are kind of moving by halves here, so looks a little bit weird, but and then let's look and see what happens with the k. Right? So as it's getting more and more negative, it's going down, and as it's going positive, it's moving up. All right, so that one kind of does what we think it should when it's positive, right? So here we'd have like that +2 is where it would go in place of that k. All right, so let's look at this one next. So on this, we want to think, well, how could I change the values of h and k, so move my sliders, so that the blue graph goes exactly, blue graph translates onto the dotted red graph. Right? So if we're like trying to, move this and stuff, so right now,
do we scooch the H over left?
Yeah, so how many places are we going to need to move that left?
I'd say 1, because we're on,
Yeah, it looks like 1. And then how about to get it
down 1?
Yeah, so we want to go down 1 there. All right, so that's just going to kind of help us see what's happening on this. Let's look at one other graph here. So now this time we're just focusing on that A. So the A does quite a bit on here. right? But we want to look and see, predict, what we need to change this to be so that it's on that red graph there. And so we can see that it needs to get wider, right, to line up here. So which direction should we move that slider?
Right.
Let's see, if we move it right, this is happening.
Oh, left. Yes.
Yeah, so if we move it left, all right, we can see, yeah. And so it looks like that's when A is 1. All right, so we just have to kind of keep looking at it, and see if you go between 0 and 1, notice how it's getting wider and wider and wider. Okay, and 0 is just a, a flat line there. That doesn't graph a parabola. A can't be 0 on there. And then when it goes negative, right, it's going to be kind of a wider parabola there until you get past that -1. Okay, so that is a lot of what we're going to be talking about today. So let me go back to what we have over here, and let's talk about the stuff that's in this box now. So in the lecture notes, it gives you these things here. So we're comparing everything to that parent function like we talked about before. And so the h value represents the horizontal shift, right? And so that means it's going to be moving left or right. But so if h is subtracted from x, the parabola shifts to the right. If it's added, then it shifts to the left. And then k, when it's positive, it shifts up. And if it's negative, it shifts down. All right, that's kind of what we were showing over here. But then A, wow, the A does a lot of things. All right, so if it's positive, then we know it's going to be a right side up parabola. And if it's negative, it's going to be an upside down parabola. But then remember, if A is bigger than 1, then it's getting really, really, really skinny. So the higher that number gets, the skinnier the parabola gets. Okay? And then it's saying here, it gets wider when it's between 0 and 1, like we were showing over here. Right? That's making that wider. Okay, so that's just what this stuff in the box means. So make sure you write down, things that are going to help you, like write it in your words so that you understand what each of those things are doing. The other thing that I want to talk a little bit about, and we'll talk more about it in the next section, but it's about this maximum and minimum. So let me change this again so you can see it's upside down here. So if we have this right side up parabola, this red one, all right, and we're thinking, okay, does this have a maximum or a minimum? Well, the arrows aren't showing on here, but this is going up and out forever, right? And so there's no highest point that it's ever going to get to because it goes out to infinity. But there is a lowest point, and that lowest point here is going to happen at the vertex. Okay, so the vertex is a really important part of our parabola, and that's what we're going to be focusing on since we're talking about vertex form of a function. But if it's an upside down parabola like this one, right, we can see that, oh, now that vertex would be the maximum because it's the highest point of an upside down parabola, because these go down forever. So there's never going to be, like that goes down to negative infinity, goes on and on and on forever. Okay? And then also want to talk about how h comma k is the vertex. So let's go to this next one here. So again, looking over here, I can see, all right, here is the graph of y equals x squared. But I want you to figure out, how could I graph this equation instead? So I'm trying to think, how is this changing the graph, and how is this changing the graph? Okay, so let's first start with that 4. What is that 4 doing?
That 4 is the K, so that shifts up or down.
Yep, and since it's positive, it's going to shift it up 4 places, right? But that's not all, right? It also has a shift left or right. And so this, when it says x minus 2, a lot of times people think, oh, I've got to go left 2 places. But that's actually not the case. What we're really thinking about here is, think about the stuff just inside our parentheses. And if we think, what value of x would make that 0? Well, that would be positive 2, right? 2 minus 2 gives me 0. And so sometimes, like, just to help you remember this, because it happens on all these different types of functions, not just these quadratics, but if it's inside something like this, in parentheses, or maybe inside a square root, or inside absolute values, then you're actually moving it the opposite direction than what it looks like. So I say, think insiders or liars, right? So if it's inside something, then you're kind of doing the opposite of what it looks like. So that means our vertex is going to be, so we're going to go right 2 and up 4. So my vertex is here, right? And then my A is in front of this, but there's an invisible 1 there, right? If there's no number in front of that parenthesis there, then that means it's 1. And so you can kind of use that to help you get the shape of the graph a little bit, because we can kind of think of it as slope just for 2 points here that we're going to be plotting. So if we wanted to know where the next point would be on this parabola, we know it's going to be a right side up parabola, right? But if I go rise over run, up 1 over 1, then I'm going to have a point there. And if I go left 1 and up 1, I'll have a point there. And then I can see, all right, that is going to be the shape of my parabola, kind of. And we'll talk about how you can find, other points and stuff. But for right now, I just kind of want to make sure you, have like a rough sketch of what that looks like. All right. So when you're describing it in words, right, think about how it's being shifted, right? So we would say it's shifted, 2 places to the right, or 2 units to the right, and 4 units up. So that's what we can say here, all right? And our vertex, let me write it in here, it'll be kind of big here, but our vertex would be positive 2, comma 4. And those, you can kind of see that those show up over here in the equation, right? So opposite of what's inside, and then exactly what that is. Okay, do you have any
really
questions?
Quickly,
Yeah.
You're perfect. So I follow closely, but the square root of 2, I was confused of where that came in.
So I was just giving an example. There's no square roots in this one.
Okay.
But I'm saying for other functions, quadratic functions are raised to the 2nd power, so they're being squared. But we'll also talk about cubic functions, which are raised to the 3rd power. We'll talk about absolute value functions, and we'll talk about square root functions. So those are just different functions, but they follow these same kind of rules that we're talking about here. So yeah, thanks for helping clarify that.
Yeah, because I understood the x was 2 to make it 0, but then there was a 1 in front of the x. But then I was like, well, where does the 2 come in?
Yeah, so that squared is just telling us that it's going to be a parabola shape.
Okay.
Yeah, so you might want to write that in your notes, that square is just telling you the shape of the parabola. Because if it was raised to the third power, it's going to have a different shape to it. It kind of looks like this. That doesn't look very good, but you know, but it has a different shape to it. So, and then everything kind of shifts the same way that we're talking about in this. But we just have a different shape to start off with. Does that make sense?
Mm-hmm.
Okay. All right, so on this one, I want you to tell me, where would the vertex of this be?
3.
So our vertex needs to be written as an ordered pair, right? It's a point on the graph. So something, comma, something. So what is our, or, you know, so remember we said over here, it's H, comma, K. That's our vertex. And remember, here's where my H is, and here's where my K is.
Mm-hmm.
Okay, so looking at this, what value of X here would make the stuff in the parentheses go to 0? So what plus 3? Yeah, -3, right? -3 plus 3 is 0. Or you can think of it the other way, where you're just thinking insiders are liars, so it's not +3, it's going to be -3. So that's my, like my X coordinate of this. But then my H, or sorry, my K, we did our H, the K is just the number that's out here. And so since that's a -1, that's what we'll write in here is -1. So that's where my vertex is. And so if we set it in words, like how it's different, right? This -3 is telling me it's going to be shifted 3 places to the left and then 1 place down. Because remember, this is telling us our left and right shift, and then this number is telling us our up and down. Okay, let's look at another one here. So I just went over that. Go to this next one here. Okay, so now we have a number besides 1 out in front of this. So again, when we're thinking about this, how is this, you know, how does it compare to that parent function of y equals x squared? So let's just start here. So this is our a value. So if it's a 2, how is that changing it? So we said when it's bigger than 1, right, it's going to become more narrow.
Yes.
Okay. And I'm going to go back to a graph so you can kind of see what we're doing here, so you can kind of understand that. But so that's making it skinny, right, by a factor of 2. And then what would my vertex be, or how is this being shifted? So this is
1.
Okay, 1 place to the right.
And 3.
And up 3. Right? So when we write it out in words, we'd say, you know, skinnier by a factor of 2, move 1 unit up, or sorry, 1 unit to the right, and then 3 units up. Okay. So let's take a look. Let me go back to, sure. Yeah, let's do this. So let's put this in. So let's see, A was 2, all right, and then H was, what was it again? I can't even remember. -1 and then +3. Okay, so let me put these in here. So -1 and then +3. Oops, what happened there? All right. Oh, wait a minute. But this isn't going to be a -1. This one gets a little bit confusing because it says in our formula, it says x minus 1. But
that makes it 0, right?
So 1 is what makes it 0, right? So I should have put a 1 in here, not a -1. And now we can see that that's what's happening. It's making it skinnier. It shifted it. So if it started here at 0, 0, right, it would shift it over 1 place and up 3 places. Okay? Mm-hmm. So that's just, so we can look at this and just kind of get a visual idea of what these are looking like. Okay. All right, how about on this one? What would this 1/2 be doing?
Did we change it?
So if it's between 0 and 1, right? We said that it was going to
still be thinner.
Is it going to be skinnier? So let's see. Let's go over here. Let's do our A again. So, all right, as we get between 0 and 1, it's making it wider. It's kind of hard to see on that one because it doesn't move it a lot. Let me go back to this one. So here, right, when it's, so it was 1/2, which is 0.5. Mm-hmm. All right, and do you see how that's wider than what our parent function is? So the parent function's in red, and it's a little bit wider than it. All right, so that's making it wider. And then what about this stuff inside there, right? And then this one, how are those shifting it? So what's happening here?
4.
Which direction?
-4.
Uh-huh. So to the left 4 places.
And then down 1.
And down 1. Right? So if I was to try and, graph this, let's see. I think the last one gives me a place here. All right, so it was 1/2. What was our H again? Negative.
I want to say it was, yeah.
-4, I think. And then this was -1. All right, so we can see, and I don't like that this red one isn't at 0, 0 because it's hard to compare there, but imagine that there was, one right here where the vertex is at 0, 0. Mm-hmm. So from there, we're going 4 places to the left, down 1, and then you can tell it's just a little bit wider. But notice something here, right? So if I'm trying to go from, let's see, what's happening there? Did I do that? Oh, yeah. Okay, yeah, these are moving by 1. Sorry, I was trying to look at the scale on here to see what's happening there. But so that this is like 1/2, all right? And so with rise over run, we'd say, well, this one isn't lining up quite right. Why is it doing that? Sorry, I just want to make sure that I can see it on here. Maybe this will be a better one to look at. Yeah, these are all kind of a little bit ski-wampus. Maybe I'll just have to go to, let me just go over here to this graphing calculator. So if I put in this y equals 1/2, and then I think it said x plus 4 all squared, and then minus 1. Right. All right, so when we're looking at this, right there, that's where our starting point is, but then we can kind of see that it's going, it's kind of like the slope here, not exactly, because this is moving, it's going up 2 over 2, which it shouldn't be doing that. to get to that next point. So I'm just kind of like, because usually like that's kind of like the slope. It should be going like up 1 over 2. But that's not what it's showing here. Let me think about what's happening there. And so that can be some way that we're going to talk about, though, how we can do some of this graphing on here. Okay. So I'm going to kind of skip through some of this stuff. This is just, you could go through, like use this Desmos graphing, calculator thing and just follow these directions and kind of, get an idea. But it's basically what we just did on that Desmos activity. But it kind of just guides you through it. Okay. All right, so let's look at this and how we would graph it. And we also need to talk about the axis of symmetry, because it's going to ask you that on the homework. All right, so on here, let's see, if we were asked to find the vertex of this, because we need it, that's an important part of it. Let me change the color here. Okay, so let's think about this. What would the vertex be?
-3.
Mm-hmm.
-4.
-3, -4. Okay, so we know that's going to be left 3 and down 4. So that's going to be our vertex point. And then we can see that our, slope on this is 1. So we can kind of do our rise over run, which would be up 1 over 1 and up 1 over 1. But it's also on the homework going to ask for the axis of symmetry and the y-intercept. So let's talk about how we can find those things. Well, the axis of symmetry is always, always, always going to go through the vertex. So what I mean by this is, so parabolas have symmetry. This isn't a great dotted line, but so imagine, if we have our parabola here, if it was folded over that line, so I guess you can kind of look at this one here and see, if it was folded on the line there, it would be exactly on top of each other, right? A mirror image is what we have going on here. All right, so our axis of symmetry, or sometimes I call it a line of symmetry because I want to make sure that students remember that you're going to write it as a line, right? So line of symmetry, we got to write it as an equation. So that's going to be, it's a vertical line, so it's x equals some number. And what is the number?
-3.
-3, right? So that is the line that goes through. That makes that's where our symmetry line is. Okay, but then let's also talk about how to find the y-intercept, because like I said, they're going to have you do that also. So the y-intercept means we're going to let x be 0. So I'm going to put 0 here in place of what I have x, and then figure out what y is. All right, so if I do that, I'm going to change that f of x is the same thing as y. So I'm going to change this to be y equals parenthesis. Remember, I'm putting 0 in place of that x. So 0 plus 3 squared, and then minus 4. So now let's follow order of operations. We've got to add these guys together inside the parentheses first and then square it. So 0 plus 3 is 3, squared is 9. So y equals 9 minus 4, and simplify that, we get 9, or y equals 5. Okay, but I want you to write that answer as an ordered pair, because I want you to get in the habit of thinking of like y-intercepts, x-intercepts, they are points on the line, right? So that right there is an x-intercept, that's an x-intercept, and that's a y-intercept. And notice how, they show these on the graph because these are important parts of the graph, okay? So that's why they kind of show up there. So this, we said x was 0, so we'll have 0, comma, and we found y to be 5. So 0, comma 5 would be that. So let me put that up here. So over 0, up 5 is right here. And then the cool thing about parabolas, like I said, they are symmetric. So notice how these down here, right, are 1 away, like they're 1 unit to the right and 1 unit to the left. Right, they have that same distance both ways. And up here, we can see, all right, our axis of symmetry is 3 units away from where this is at, all right, 1, 2, 3. And so if I go 3 units past that, 1, 2, 3, I know another point is going to be over there, just to be able to make that symmetry. And I know this isn't going to look great. It's always so hard for me to do this on this tablet thingy, but oops. Oh my goodness. I want to make it better than that. Okay, but it's going to go up through that point. So something like that is what our graph is going to be. All right, do you have questions on how we found the vertex, the line of symmetry, or that y-intercept?
No, I think it was very clear.
Okay. All right, so let's do a couple more here. So this time, let's do the one right below it. Okay. So again, let's figure out where would our vertex be. Because we need to find these things before we can graph it. So our vertex is going to be
1,
comma 5. Awesome. So over 1, up 5 is going to be here. All right. And then notice my slope this time, and I'm putting slope kind of in air quotes because it's not really slope. Slope is really linear, and so like it's the same like rate of change all the time. But we can find some of the points by doing this. So if we think of this as kind of the rise over run from there, then from this point we're going to go down 2 and right 1. And then we're going to do the same thing, go down 2 and left 1. Okay. And so I can see, okay, my parabola shape is kind of starting there. Where would my line of symmetry be then?
Is it on 5?
Let's see.
Or
so are we going that way? We're going this way, right? Remember, it's the x because we have to do a vertical line. So you're right, though. It is, part of that vertex, but it's always going to be whatever that x value is. Because remember, our line of symmetry is going to be x equals 1. So that's what it has to go through that vertex. Okay. All right, and then our y-intercept, we actually already found. Do you see that's where it's crossing the y-axis is right there? I mean, you could go through and do the steps on this like we did before, but you still will come out to be this 0, 3. All right, and so that's kind of all the information we really have there, but we could just kind of, let's see, let me use a different color. Just try and show what this would kind of look like. Ooh. So it's supposed to be looking kind of, skinnier. I wish this wasn't so hard to do on here. There we go. Okay, but it should look kind of skinnier than the one that we did before, where that was a 1 out in front. Okay, what about this one? This one right here. Because this one's it looks a little bit different. So let's start off again. What would the vertex be?
4.
So 4, comma what? So this is kind of tricky because, I mean, there's nothing there for my k, so it's kind of saying like plus 0. You see that? And so because we don't have anything in that k place, so that's going to be a 0. So my vertex is going to be 4, 0. So over 4 up 0 will be here. All right, and then let's kind of do this slope thing here, the 3 over 1. So I'm going to go up 3, 1, 2, 3, and right 1. and over 1, up 3 this way. So we can kind of see that is, getting skinnier. And it's positive, so that's why, it's going to be a right side up parabola there. And when we figure out the y-intercept, let's do it really quick, but you'll see it becomes a big number. It would be going off the graph here. But it still might ask you to find some of these and not graph it, so I want to make sure it's clear how we do that. All right, so to find the y-intercept, we're going to go look at the equation, and we're going to put a 0 here in place of that x. So let's write that down. So I'll have 3 times 0 minus 4 all squared. All right, what's negative 4 all squared? Going to be 16. Negative 4 times negative 4 is 16, because 0 minus 4 is negative 4. And then we have to square it. And then 3 times 16 is 48. So that's going to be clear, off of this page. But sometimes on the homework, it won't ask you to graph it. It's just going to ask you to find the vertex, the axis of symmetry, and the x-intercept. So or y-intercept, where is the line of symmetry on this?
4.
Okay, but not just 4. We need to write it in a certain way. You got to write it as an equation, like we did here and here.
X equals 4.
Yeah, so you've got to have that x equals. If you leave that part off, like on the exam, you are going to miss it. It has to be written as an equation, okay, because that's what it is, and it's telling us that it's this line, this vertical line going down here. Okay, and then let's see, let me just use the green again so we can kind of see what this is going to look like. And it should look skinnier, right? Because that 3 is telling us it's going to be a skinnier parabola. But I hope yours are looking better. I don't know why it's so hard on here. I can do it so much better on the board than I can on here. I don't know. Okay, so is that making sense with the vertex form we're doing
yes.
there? Okay, because understanding that part is actually going to make the next section a lot easier to understand. So this was vertex form, and then our next section, 3.4, is going to be about graphing these in intercept form. All right, so intercept form looks like this. All right, so we have A, and then in parentheses, x minus p, and then in another parenthesis, x minus q, and p and q are the x-intercepts. So on the last one, we didn't talk about the x-intercepts at all. And we'll talk about them in Module 6 when it's in that form. But for right now, that's all we're going to do with those. And then A does the same thing that it was doing on the last one, right? Makes it skinnier, wider, flips it upside down if it's negative and stuff, okay? So yeah, so these are, again, some important parts of our parabola. All right, so we've got our axis of symmetry, and then notice how, if I have something that is 2 units away to the right, then I also know there's going to be another point 2 units to the left. Okay, so understanding the axis of symmetry can be so helpful on this. All right, but before we can kind of find the x-intercepts, and that's why we like the intercept form, because it's super easy to find the x-intercepts. And we like vertex form because it's super easy to find the vertex when it's in that form. Okay, so, but we need this zero product property. So basically I'm saying if you multiply 2 numbers together and it equals 0, then one or the other number would have to be 0, right? I'd have to have like 3 times 0 gives me 0. Or I'd have to have 0 times 3 equals 0. Or if I did 0 times 0, I get 0, right? So one or the other of those factors has to be 0. So how that helps us is that we can say, okay, I'm going to let my f of x equal 0. So I'm going to put 0 in place here and then write the rest of this down. And so all of these are factors. These are connected by multiplication. And that's what's happening here. They're connected by multiplication. So I'm going to take each of these factors and set them equal to 0 and solve to see what happens. So if I do this first part, that -2, put it equal to 0, well, hopefully you'll notice there's no x to solve for there. And -2 does not equal 0, so this is not something we're going to mess with. All right, we're just going to look at these other two parts, these other two factors. If there was an x out in front, we would have to do something with it, and we'll have an example like that here in a minute. Okay, but let's just take those two factors and put them equal to 0 and solve them. So I'm going to take x minus 3 equals 0 and x plus 5 equals 0. And then just solve them like we normally would. Get x by itself, so I need to add the 3 over, so x equals 3. And then subtract the 5 over, so x equals -5. But again, notice it says write your answers as ordered pairs. Okay? So when I'm dealing with a parabola, oftentimes there will be two places where it's crossing the x-axis. You see that that happens here and here. All right, there's two places where it's crossing. So we're going to have two different points. Okay, now let me caution you, because this is what I see people do a lot on the exam. They say that the x-intercept is 3, -5. And I want you to think about why that can't be the case. Well, if you draw that point out, right, over 3, up 5, that's not going to be on, on that x-axis. So that's not an x-intercept. And also notice that both of these say x equals and x equals. So I can't put, that -5 there because that's an x, not a y. Right? And so when I'm dealing with that. Okay, so again, I'm going to cross that out just to hopefully make sure you remember, don't do this. Okay, I have two different points on this. So my first one, well, I know x is 3 and y is 0. Right? That's what we put in here. F of x is the same thing as y. And then x is -5 and y is 0. That looks weird. Okay, so those are my two x-intercepts. That's what I just found. Okay, what questions do you have on that one?
Nope, I'm still with you.
Okay. All right, so now let's do this one. Okay, again, we're going to put 0 in place of our f of x. We've got to set this equal to 0 in order to solve it. But again, that 3 out in front is nothing that we need to mess with. There's no x there to solve for. So let's just take those other two factors, the 2x minus 7, and put it equal to 0. And then 5x plus 1, put it equal to 0. And then let's solve these. All right, so to solve this, I need to start by adding my 7 over. So I get 2x equals 7, and then divide by 2. So x equals 7/2. All right, or 3.5. Right, it's 3.5, but we'll just leave it like this. All right, and then kind of similar here, let's start by subtracting the 1 over. And then I see that 5 and x is connected by multiplication. Whoops, why did I put a 0 there? It should be a -1. And then we'll divide by 5. So x equals -1/5. All right, but again, we've got to write our answers as ordered pairs. comma in between that too. All right, so tell me what one of the points is going to be.
-1/5. 0.
Comma 0.
7/2 and 0.
Awesome. Okay, so do you see how having it in this form is super easy to pick out where those x-intercepts are? So we like that because x-intercepts tell us a lot about a graph. Okay, so let's do the whole thing now on this one. So now we're going to take this in intercept form, and now I'm going to show you how you can find not only the x-intercepts, but we can find a y-intercept, we can find the line of symmetry, and we can find the vertex. And by having all of those parts of the parabola, we can put it together and then graph it. Okay, so we've done the x-intercept stuff. Right? And we said, okay, we're going to let put 0 equal to that, which means I just need to take both of those parts and put them equal to 0 and solve it. And sometimes you can do these kind of in your head, but I'm just trying to make sure that everybody is with me. All right, so if I'm subtracting that over, I get x equals -2. Subtract this over, I get x equals -4. And then I need to write these down as ordered pairs. So here I'll have -2, because that's my x, comma 0, because I put 0 in place of that y, right? F of x is the same thing as y. All right, and then my other point is going to be -4, is my x, and 0 is my y. Okay, so we got 2 points on the graph. Awesome. All right, but now let's try and find the y-intercept. So just like we did on the last one, we said for the y-intercept, you're going to let, whoops, I'm going to do this in a different color so it doesn't bleed into those. All right, we're going to let x equal 0 and then solve for y. All right, so if I do that, I'm going to just write this down, that f of x is y. So I'm going to put y equals, and then in place of my x here and here, I need to put zeros in there. So I've got 0 plus 2, and then times 0 plus 4. Well, 0 plus 2 is just 2. 0 plus 4 is 4. And when I multiply those together, I get 8. Okay, but again, I'm not just leaving my answer like that. I've got to write it as an ordered pair. So I let x be 0 this time. So 0 goes here, and my y is 8. Okay. All right, so we've got 3 points on here already. Let me scroll up and let's just kind of put these points in here so far so we can see what's happening so far here. So over -2 up 0, so there's one x-intercept, and then -4, 0 is there. And then I know my y-intercept is 0, 8. So over 0 up 8 will be there. All right. So now we want to find the line of symmetry and the vertex. Now, this is kind of different because before, like in vertex form, we could find the vertex really easy, and then it was just the line of symmetry corresponded with that x coordinate. But this time, we're going to have to do something a little bit different. Okay? So since a parabola is symmetric, and that means that they're exactly the same distance away from each other. So if I take my x values, right, let's see, I'm going to do a different color here. I'm going to take this x value and this x value, and I'm going to add those together, so -2 plus -4, and then I'm going to divide it by 2. And that's because we're finding the average, right, or the midpoint, if you will, right? Halfway in between these 2 points. And this one's kind of easy to see what it is, like visually and maybe thinking about it, but let's figure it out because they're not always. So -2 plus -4 is -6, divided by 2 is -3. All right, so my line of symmetry is x equals -3, and that's right here. All right, so let me kind of try and do a little dotted line here so we can kind of see that's what's happening. Okay, and then now we can use this x value to help us figure out the other part of our vertex. Okay, so for my vertex, I know that x equals -3. So let's go ahead and put in -3 right here. But then we need to find the y. And we can find the y by plugging that -3 back in place of x. So let's do that up here. So I've got y equals, all right, I'm going back up here to this first equation. In place of my x, I'm going to be putting -3. So I'm going to have -3 plus 2 times -3 plus 4. And then I just need to simplify this. So let's simplify inside the parentheses. That's going to give me -1. Simplifying these parentheses, it's going to be +1. -1 times +1 is -1. So y equals -1. And so that is my other part of my vertex. Okay, so now let's come to here and finish graphing this. So let's see, so we'll put our vertex, so it's at over -3 down 1. Right? And then we have this point up here that's at y-intercept. How can I find what the other point is on this side? How many places from that line of symmetry do I need to move to get that? So it's on the same line here. So I'm looking at him saying, okay, this was
over 3.
Yeah, because it's 3 places this way, so I need to go 3 places the other way. All right. Now let's see. Let's get rid of those dotted lines. That looks kind of weird there. But now we can see, all right, I can see where that U shape is at here, right? So it's going to kind of go, oh my goodness. I need to not, I guess maybe I just need to practice a little bit more with this. I don't know why it's so hard. Oh my heck. Yes. Okay, just kidding. That looks horrible. But so imagine that's a smooth graph and it's a U-shaped graph there. Okay. And then the last thing that you're going to need to do is tell whether it's the parabola has a maximum or a minimum. So on this one, what do you think? Is there going to be a maximum or a minimum? So if we're thinking, do we have a highest point or do we have a lowest point?
Lowest.
Yeah, and so the maximum or minimum is always going to be at the vertex. So you want to look at the vertex to help you figure that out. All right, so if we're looking at that point, we're saying, okay, that's the lowest part of the graph. So that means it's a minimum. And then it's just asking, what's the point where it is that minimum? And it's the same as the vertex that we listed above, which is -3, -1. Okay. Does that make sense?
Mm-hmm.
Okay. Let me think here. Let's do this one. I think this might be our last example to go through here. But let's do all of these different parts again. But this one looks a little bit different because we didn't have, like before, we had like 2 sets of parentheses like this, right? But we don't have that anymore. But we still have 2 factors. So this is one factor, and then this is the other factor. So those are the two things that I'm going to set equal to 0. So I'll have negative 2x equals 0. We'll solve that, and then we'll do x plus 3 equals 0. Well, on this one, if I divide both sides by negative 2, 0 divided by anything is just 0. So x equals 0. And then on this one, like we've done before, just subtract that 3 over, x equals negative 3. Okay, but then we need to write those intercepts down, these x-intercepts, as ordered pairs. Now this is kind of funny, right? Because so let's put these in. So we said x is 0, and our other x is negative 3, right? But remember, we put 0 in place of that y, so we've got the point 0, 0, and negative 3, 0. So those are our two intercepts. Okay, now our y-intercept, again, remember we're going to let x equal 0 and solve for y. So on this one, let's do, so y equals negative 2 times 0, putting 0 in place of that x, and then parentheses 0 plus 3. All right, so if we simplify this, we see that we've got negative 2 times 0, right, is 0. And then 0 plus 3 is 3. 0 times 3 is just going to give me 0. So do you see we already found it up here? This is an x-intercept, and it's also the y-intercept. Right, so if you have the point 0, 0 on your graph, it acts as both the x-intercept and the y-intercept. Okay, so how would we find our line of symmetry? So again, we said, okay, let's take those x values and let's add them together and divide by 2. I want to figure out halfway in between these 2 points. So 0 plus a negative 3, and then all divided by 2. So I've got negative 3 over 2, which I'm going to change it to a decimal just so it's easier to put on the graph. But just know on your homework, it won't give you, you won't come out with a decimal answer because it can only move by, units of 1. It's not going to move in like half units or third units or anything like that. Okay, but okay, so then our line of symmetry though is x equals negative 1.5. All right, and then finding the vertex on this, we're going to take that x value that we found, and that's going to give us our x coordinate of our vertex. And then how are we going to find that y? We know the x, how are we going to find that other part of our vertex? I'm going to just
have to look at my last step.
Yeah. So if we go back to our original equation here, all right, and we know what x is, we can put x in both places, or sorry, we can put negative 1.5, I should say, in place of both of those x's. So I'll have y equals negative 2 times, actually maybe I will leave it now as negative 3/2 just because it might be a little bit easier to simplify this here. And then times, and then we'll just have, I don't know if which way you're going to want to do this, but I'll just use the 1.5 on this because it might be a little bit easier there. But the reason why I did this is I could see, oh, those are going to divide out. All right, and a negative times a negative is positive, so that's going to give me a positive 3 on that part. And then we need to times that by 4.5. And then when we multiply those together, we'll get our answer. What is that? What is 3 times negative 4.5?
negative 13.5?
Yeah.
Shouldn't
should
the
be.
1.5 be negative?
It should be. Sorry. Thank you so much. Let's try that again, right? That's not going to be 4.5, right? Because we're now doing really 3 minus 1.5, which is just going to be 1.5, right? So sorry, let's change that to a 1.5. Thank you. And now when we multiply that, 1.5 times 3, that's going to give me 4.5. All right, and let's see. And it should be positive, right? Because both of these were positive. Had a negative times a negative made a positive. And then this is going to be a positive 1.5. Okay, so we have 4.5 is what I get for my other part of that. Okay, and then you can just graph all of those points that we found on here and then just see what this is going to end up looking like. So let's do that. Try and get these points here. Let's see. Let's do and our y-intercept was the same there, so that's kind of all we can do. But we should also, mark on here that the line of symmetry, it's supposed to be going halfway in between there, right? Because it's negative 1.5. All right, and then connect those dots together to make a U-shaped graph, and you will have what that is going to kind of look like. All right, so 2 different forms, right, that we talked about, vertex form and intercept form. And they both are great, but for different reasons. And then next time we're going to talk about even another form that's called general form and kind of tie it all together about these different forms here. All right, so one last question here. Is there a maximum or a minimum?
Minimum.
Okay, a minimum. And wait a minute, what happened here? -2.
Isn't the graph flipped because of the
It is.
-2?
So what happened on this? Oh, because it was positive 4.5, huh? And I went down 4.5, so that was my bad. It should have been the other way. Because, yeah, I just looked at that too, and I was like, wait a minute, there's a -2 out there. Let's see. Let me undo some of that. Oh, gosh. Why won't it let me choose the eraser? Okay, so that point should not be there. It needs to be, we've got to follow what it says here, right? So let's do that. So if I've got this, so it should be over 1, or negative 1.5 up 4.5, so that's here. And then, yeah, it should be going upside down because it is, right, that number out in front is negative. So that's telling us.
So now that makes it a maximum, right?
Yeah, so now we're going to have a maximum at that point. All right. And the point is, again, negative 1.5 comma 4.5. All right, whatever the vertex is, that's going to tell you either your maximum or minimum. And that just depends on whether it's right side up or upside down. Okay. All right, well, make sure you're working on the homework and try and, work this, weekend on getting done up through this 3.4 because we're going to be building on these ideas next week. So understanding these well will be really important. Okay?